Here in this video, we are solving a problem that appeared in NEET 2025. It's basing on Vernier Callipers, maybe a part of a very first chapter or even before the first chapter, right? Let me read out what is the question is, right? Consider the diameter of a spherical object is being measured with the help of Vernier Callipers. Obviously, it is kept between the two jaws of the Vernier Callipers. Suppose it's 10 Vernier scale divisions. So whatever may be the problem is, okay, I'm not reading it right now. I will read it little slow. Then what we have to find out is what is the measured diameter of that wire, including zero correction, right? So I will start from there and then I'll come back to the problem, right? So the final reading of the Vernier calipers is, how do you calculate that? So let's come to the reverse way, like what do you want, so that we can go and find out what is needed, right? Final reading using a Vernier calipers is main scale reading MSR plus Vernier coincidence, Vernier scale coincides at a particular value with the main scale, multiplied by least count, and then plus or minus error if there is any error, right? So this is what the reading is, right? So what is the main scale reading is 5 centimeters, that is available for you. What is the Vernier coincidence is, that is given in the problem, that the Vernier coincidence is 8. So I know this value already. I know Vernier coincidence already. And look at the error, right? When the main scale reading is this much, number coincide 8. Here, right? And Vernier scale is at 0.1 centimeters when the jaws of Vernier calipers are collapsed. That means it's already having, it is supposed to show 0, but it is showing a higher reading of 0.1. That means it's an extra reading. So it has to be eliminated, right? So in our case, we have to write a minus error because it is showing already an extra. So I know this part also. So the only thing, so main scale reading is 5, Vernier coincidence is 8, error is 0.1, all in centimeters. So what I need to solve this problem is, I need to find out the least count. So what is the least count? That's the least reading that we can measure using that device. So we can calculate least count using the Vernier calipers as 1 main scale division minus 1 Vernier scale division. One main scale division is known for me like 0.1 centimeters. It is already known for me 0.1. So if I have to solve the problem, I need to find out what is 1 Vernier scale division is. For that, lot of data is given for you, right? So let's go there that way. Let's proceed that way and try to solve the problem. Yeah, let us see. So it is given in the problem that 1 main scale division is 0.1 centimeter or 1 millimeter, right? It is given that, suppose its 10 Vernier scale divisions are equal to 9 main scale divisions, right? So 1 main scale division is 1 millimeter. Then 9 main scale divisions are 9 into 1 millimeter. That is obviously 9 millimeter. It is being said in the problem that 10 Vernier scale divisions are equal to 9 main scale divisions. That implies what I can write? 10 Vernier scale divisions equal to 9 main scale divisions, but 9 main scale divisions already I have found it as 9 millimeter. That implies 1 Vernier scale division is 9 by 10 millimeter, right? So that's the value. If you want it in centimeters, by 10, because 1 millimeter is 1 by 10th of the centimeter. So 1 Vernier scale division is 9 by 100th of centimeter. Once if you know 1 Vernier scale division, Now I can find out what is the least count is. Now we are coming to the problem, quite easy. Yes, that implies least count is 1 main scale division minus 1 Vernier scale division. 1 main scale division, I am writing it in centimeters, 0.1 centimeter, minus 1 Vernier scale division is 9 by 100th of centimeter. So 0.1 is 1 by 10th of the centimeter minus 9 by 100th of centimeter. 100 is the LCM, 10 minus 9, that is 1 by 100. So least count in the problem is 1 by 100th of centimeter. Once you got the least count, I can go directly to the problem and solve the problem. Now it shall be easy. That implies final reading of the Vernier calipers is main scale reading. It is given that the main scale reading of the diameter is 5 centimeters. I am writing everything in centimeters. Notice that. Vernier coincidence, it is given that the Vernier coincidence is 8. Least count is 1 by 100. I am writing everything in centimeters. And then plus or minus error. That error is minus because it's already showing an extra 0.1. That is also in centimeters. So what's my answer is? Yeah, 5 plus 0.08 minus 0.1. 5 minus 0.1 is 4.9. So the answer is 4.98 centimeters. That's the answer for the problem, right? So be careful to solve this problem. You need to know some basic things like how do you measure the reading of the Vernier calipers. This is the basic final rule that you need to know. Now I need to know further how do you calculate least count. To measure the least count, this is the formula that we have. Once if you apply the data and do and find out the least count, solving the problems becomes an organized effort, right? That's how you have to solve the problem. Thank you for watching.